Microsoft Azure provides a multitude of tools and components that help data scientists perform their machine learning objectives. Specifically, Microsoft provides what's called Azure Machine Learning Services. Now, Azure's machine learning services are cloud-based, and that also means that you can access them through your browser or with your own code, but via an API. Now, it also means that your actual machine learning that Azure performs can make full use of the near infinite scalability of Microsoft's cloud data centers. Now, with Azure's machine learning services, you can also create your own models based on your own data, algorithms, and conditions. If you want to predict the price of cars, let's say, based on their characteristics, you can do that. If you want to predict whether a patient is diabetic based on various medical statistics, you can do that too. And of course, once you have a model, you can manage it too. And that means tweaking the algorithms, tuning your model's variables, or even running different experiments to get the best possible outcome. And once you get that outcome, you can use Azure to publish your model and put it out into the wild so that it can be used by customers. Now, one of the biggest advantages of Azure's machine learning services is that it's designed to be understandable and usable for everyone. Now think about it. Whenever you use a new tool, what's one of the biggest reasons that you'll abandon that tool? Well, it's slow and cumbersome, so you'll throw it out and find something else, right? Well, Azure's tools are very quick and easy to use. Whether you want to build a model, explore experiments, tweak parameters, or deploy an endpoint, accessing those tools is very quick and easy to do. And that's the other part, it's easy. While the tools definitely allow for deeply knowledgeable data scientists, they also allow for beginners. The tools don't require deep experience to use, and that makes sense. A lot of us are embarking on AI and machine learning for the first time. We need to get our feet wet and be guided by Microsoft's tools to do exactly that. Now, at the end of the day, what Azure's machine learning service is helping us do is build models. Again, let's say you wanted to predict the price of a car based on characteristics of that car. You'd need to build a model to do that. And Azure's tools help you to define datasets, cleanse your data, apply algorithms, and then train, test, evaluate, and deploy your models. So how is it that Azure's machine learning services do all of this without needing the user to have a ton of experience? Well, the main way it does that is through a clean, intuitive, graphical user interface, or UI. The UI lets the user quickly and easily find the various services they're looking for, and then quickly and easily manage their resources. If you want to connect and configure a dataset, there's a section for that. If you want to configure endpoints and share the connection keys, there's a section for that too. And if you want to build models and tweak all kinds of parameters while training your models, there's a section for that too. And you don't have to write a lick of code if you don't want to. So it's really simple. Of course, if you want to write code, then you absolutely can do that. You can get as advanced as you want to get. It's just that you don't have to. Now, in Azure's machine learning services, there are some basic fundamental things that you're going to have to set up before you can ever train or run any models. And that's data and compute. Now, unsurprisingly, all of that is cloud-based. So while you might have a simple data set, you would store it in a simple blob storage. But if you have a giant and complex data set with billions of values, you would also store it in a cloud database. Then you can connect your model to that data set with ease. Now, once you have your data set in the cloud, you can then run a bunch of data experiments. And that can mean all kinds of things. You can add more data, tweak your data, use different data sets altogether. Ultimately, the idea is to train your model, right? Well, how better to do that than with data? And how better to validate your model than with lots or different data? Well, with Azure's machine learning services, you can use the built-in dataset and data store services to manage and connect to your data. You can also use Azure's machine learning services to manage your compute. At the end of the day, to run a model, you need to have compute power under the hood. With Azure, you can configure your system to have as much or as little compute as you want. With less compute, you won't have as much speed, but it'll be much cheaper. But with lots of compute, you'll arrive at your answers faster, but it'll be more expensive. So it's a balancing act. The point is to run at scale. If you're playing with the system and you're testing with small amounts of data and basic algorithms, a small amount of compute is fine. But if you're playing with massive amounts of data and complex algorithms, or you have a lot of users, you'll need more compute. Also, once you've deployed your model, you'll want that responsiveness too. Now, with Azure, you can absolutely run to whatever scale you want. So, how is all of this done in Azure, anyways? How would we build and deploy models? Well, we do that with pipelines. A pipeline is a tool that allows us to chain a set of modules together that each perform an individual task based on an input or a trigger. Each module then has an output that can be used by other modules. Now, as a data scientist, you'll build pipelines by arranging modules in a way that suits your specific situation. But why? Why do we want to go and chain these random modules together in a pipeline? Well, that's because pipelines are primarily used for training models. You can use them for data cleansing and other situations, but primarily we use pipelines to train our models. For example, we can create a pipeline that connects to a dataset, cleanses that dataset to bring it to a certain desired state, apply a regression algorithm to that data to predict certain things based on characteristics of that data, and then score and evaluate the outcome. Now, once we get to a point where our pipeline is producing a model that we like, we can then use the tools built into the pipeline editor to deploy our model. Now, deploying the model means that it can be accessed by the outside world. So imagine you built a model that predicted whether a patient was diabetic based on age, weight, sex, and other health criteria. Once you deploy the model, doctors or patients can send in their information and retrieve a prediction from your model via a simple API call. Now, using the pipeline editor allows you to do all of that simply by chaining these modules or tasks. You can also manage these modules however you want. So if there's some tweaks you want to make to how you cleanse your data, how you score your model, or even the parameters of your training algorithm, you can absolutely do that. It's super easy and super effective with the pipeline tool. Let's talk specifically about Azure's Machine Learning Studio, or ML Studio. ML Studio is a specific implementation of Azure's machine learning services. That means that it's cloud-based just like all of Azure's machine learning services. It's super easy, super scalable, and highly intuitive. The big advantage of ML Studio is that it's a fully integrated environment, meaning instead of having a bunch of individual machine learning services that you can navigate between and use individually, ML Studio brings all that together into one environment. In other words, ML Studio is a one-stop shop for all your machine learning needs. Now, what it means is that you can use ML Studio to do all of your machine learning development. So that includes the standard things like data management, compute, and pipelines, but it also means that you can go much deeper and write code modules to do whatever you need to do. But don't worry, you don't have to write any code at all if you don't want to. ML Studio is very simple to use. You can create a model quickly and easily without ever having to write a single line of code. Now, ML Studio is simple to use, but it doesn't mean that it sacrifices the ability to create and run different kinds of machine learning. ML Studio is going to be able to continue to perform your classic machine learning needs, but at the same time, it's also going to be able to help you with unsupervised learning, and that's really nice. To be able to give ML Studio a big chunk of data and then tell it that you have no idea what it means, so go figure it out, that's pretty cool. And you don't have to write any code to make it do that either. Now, with ML Studio, you can do some pretty deep learning too, and there really are no limits. And if you need to write code to get deeper into the weeds to achieve it, then you can do that without any problems. But, like I said, that doesn't mean that it sacrifices usual capabilities along the way. ML Studio still allows you to perform supervised machine learning tasks too. If you want to give the answers to a model while it's being trained, you can do that. ML Studio even includes tools to get other users involved in supervised learning. So if you have a database that has a ton of pictures of fruit, for example, you can get a bunch of users into ML Studio to help teach the model what fruit is in each of the images. Now, there are a ton of features in ML Studio. There's obviously the ability to view created models, and you can create data sets. Or you can create data stores, which is effectively links to external data sets. You can even manage system resources like compute instances or clusters, and you can view past experiments and how they did. And for those times where you actually want to run some experimental code or share information on how to interact with a model, you can use the Notebooks feature. And you have access to logs to see how things did along the way. And of course, there's the pipeline features, so you can build and train models yourself. And finally, there's the endpoints. Now, when you're all done with a model, you can deploy it and then view information about those deployments in the endpoints area. Now, ML Studio has a whole host of features as I just explained, but there are a couple of features that are really worth noting. The first is Python development. If there are times where you really need to write some code to do something specific, there are a couple of ways to do that. You can use the Notebooks feature in ML Studio to create code blocks that can be individually configured and run. You can also use them to train other users on how to use your model if you want to. But there's also the ability to drop in custom code modules directly into your pipelines. Which brings us to the drag and drop pipelines of ML Studio. Now, we've talked about pipelines already, but in ML Studio there's actually a couple of different kinds. There's regular pipelines, which allow you to visualize the work that's being done to satisfy the models, but there's also a pipeline designer. And it's the pipeline designer that allows you to drag and drop modules to train and run your models. So one of these modules could contain custom Python code. So imagine you'd spent all this time building pipelines and training a model. You've finally reached a point where the model is exactly to your liking, or at least you've reached a point where the next step is to put it out into the wild. To do that, you need to deploy your model. Well, with ML Studio, you can do that with relative ease. It's effectively a single click, and your model gets deployed as an endpoint. You can attach it to some compute clusters like Kubernetes if you want to, but either way it gets deployed as its very own cloud service that users can interact with. Now, one of the ways you can deploy your model is as an Azure Web Service. Now, what that means is that there's an API endpoint that users can touch. They can feed in the needed data and your service outputs the appropriate results. So to use the example I had earlier, a consumer could feed in information about a patient and the API would run your model and output whether it believes the patient is diabetic or not. But one of the other cool deployment types that you can do with Azure is that you can deploy your model as an IoT edge service. And that means that your model can run on the edge right where the data lives, or right where it's collected. And this can be hugely advantageous. Imagine you have some really fast-moving data that you want to apply your model against. Well, flowing that data to the cloud and then flowing the answer back is never going to be performant enough. But if your model runs on the edge... So great, you have these models and they're working in the wild. Or are they? Well, maybe over time you decide you need to make some changes to your model. So you have an update. Now what do? Well, enter MLOps. MLOps is like DevOps. In fact, it's based on the same principles. The idea is to have the ability to continuously test and deploy versions of your model. You can make modifications, build and test your mods, and then, if everything is good, deploy another version of your model. Now, all this can be done automatically. Now, just like regular DevOps, MLOps drastically improves efficiency. Each successive change, no matter how small, is deployed and usable by the consumer right away. Tests are performed on your changes to make sure everything still works as it should. The go-to-market time for new versions of models is way quicker than the traditional deployment models. Now, let's explore another feature of ML Studio. Let's pretend you really had no idea what to do with your data. You have a data set with patients with all kinds of characteristics, and you know you want to predict whether the patient is diabetic, but you have no idea what sort of algorithms are best to be used. Well, enter AutoML. With AutoML, you can provide your dataset and then choose a particular type of answer that you want, and it'll do the rest of the work for you. The only thing you need to know when using AutoML is the type of answer you want to get. So if you want to figure out if a patient is diabetic, you're really talking about classifying the data. The answer is yes, the patient is diabetic, or no, the patient is not diabetic. So you'd choose a classification model type. Now, if you wanted to predict the price of a car, you'd be producing a numeric value. So it'd be a regression model. Regardless of the model type you use, AutoML will apply all the algorithm types to your data and produce models for each of the different types of algorithms. Then the results for each experiment are scored against the actual data, and each experiment is then ranked, and the best one is presented to you in the output. There's even a way to perform time series forecasting with AutoML. Of course, that doesn't mean you can't play with or tune AutoML when you use it. With AutoML, you can choose the different types of features to use in your model. You can choose the data that you care about, like the characteristics of the car, or you can even choose the outcomes you're looking for, like the predicted price of the car. And you don't have to run all the algorithms, you can choose to run specific algorithms or ignore others. In fact, maybe you know exactly the algorithm you want and you're just using AutoML to skip the pipeline creation process, and that's completely okay. You can also set various parameters to your model if you want to. And at the end of the day, AutoML will train and produce a model. You can run the model if you want to and test it yourself afterwards. And it's also not just a run once and you're done situation either. Just like regular pipelines, if you don't necessarily like the outcome AutoML gave you, you can tweak the various parameters and run it again. And you can do that as many times as you want. Now, the advantage of AutoML is that it lets you automate the iterative tasks. With a pipeline, you select the algorithm you want to run, and then you run the pipeline. If you want to run it multiple times, you do that. Well, with AutoML, it will run as many algorithms as you want, as many times as you want. The rerun of the model happens automatically. So even without selecting the run count specifically, AutoML will take the same input dataset and run it through the same algorithm multiple times with different arrangements to get various answers. Once AutoML is finished running, it'll present you with the top 3 models it produced. Now, since AutoML is based on supervised learning, it determines which were the best models based on which ones came closest to the right answer. And since AutoML is based on supervised learning models, that means that it needs labeled data. So to make AutoML get better answers, you need more labeled data. But if you have it, AutoML is a really good option. In this demo, we're going to create and configure an Azure Machine Learning workspace. To do that, we're going to use the Azure portal to create a machine learning resource. We'll know it's working once we've gone through the creation cycle and we can navigate to our workspace in the portal. Now, before we begin, you'll need to make sure you have access to an Azure account. If you don't, you can create one for free at azure.microsoft.com/free. Okay, so the first thing we need to do is navigate to the Azure portal in our browser. Now let's create an Azure resource. Now we'll do that by clicking on the Create a Resource link in the middle of the page. Now just so you know, you can also create a resource by selecting the hamburger menu in the top left and selecting the Create a Resource option from there. Anyway, now what we want to do is create a machine learning workspace. So let's search for machine learning. Good. Now let's select the machine learning resource. And then we can click Create to get the process started. Now, when we're creating resources in Azure, we're asked for a bunch of information to help define and categorize that resource. A machine learning workspace is not much different. In fact, in the case of a machine learning workspace, we actually need references to a bunch of other Azure resources in order to run properly. The good news is that the setup page for a machine learning workspace actually asks us to choose or create those resources on the fly. So what we're going to do here is create all the resources we need all at the same time. Now first we're going to create a resource group. In my case, I'm going to name the resource group SBTest-RG. Now this is actually important. It's a really good idea to put your test systems in their own resource group because then you can clean up after yourself really easily just by deleting that resource group when you're done. And that'll automatically delete everything you put in there. Next, the page asks me for a name for my workspace. Well, since I'm not very creative, I'm just going to call it SBTest-ML. Now, Azure tries to be really helpful here and automatically assumes that I'm creating some new resources. And it names those resources based on my SBTest workspace name. So I'm going to leave those as is. Now, when you create a resource in Azure, you can create those resources in specific regions around the world. And that can be critical if you have requirements where data can't leave a certain region. It can also be critical to performance because it means all your core resources are in the same physical data center. So for this demo, you can pick whichever region you want, and I'm going to leave this as the default. Finally, we'll need to create a container registry. Now, as with most things in Azure, names need to be globally unique. So I'll name my registry SBTest-ML and then add some random numbers to it so that it more or less matches the other resources. Besides that, we'll leave everything else as the defaults. Now, we're going to skip all the rest of the tabs here and go straight to the creation step. So we'll click on the Review and Create button. And since there are no issues, we'll click on Create. Now, the process may take a little while to complete, and technically this happens asynchronously, so you can go off and do other things while this is happening. But we'll wait for this to be done. Perfect! Now our workspace is complete. Let's navigate to it and check it out. In this case, we can do that by clicking on the Go to Resource button, but obviously that button isn't what you'd see the first time you sign into the Azure portal. So let's navigate to it fresh. First, let's click on the Home link at the top of the page. Now this is what you would see when you first sign in. Now right in the middle of the screen, I can already see my SBTest-ML machine learning resource. And this is a list of your most recently used resources, so we could click on that right away if we wanted to. But then again, your resource may not always be in this list. So let's do this a different way. Let's go over to the menu on the left-hand side of the screen. In the menu, one of the options is Resource Groups, so let's click on that. Now this shows us all of the resource groups in the directory. So let's scroll through and find our resource. And once we find it, we can click on it and see its contents. Now the first thing we see when we click a resource group is its overview blade and all of the resources inside that resource group. So here we see all those resources that were automatically named for us. That container registry we created with the random numbers, and Huzzah, our machine learning resource. So let's click on our machine learning resource. And there we go. Our machine learning resource includes all sorts of blades with all sorts of different information and capabilities, from access control to monitoring. So congratulations, you've created a machine learning workspace. But now we want to make use of the machine learning workspace and access the Azure ML Studio. To do that, we simply click on the Launch Studio button in the middle of the screen. So let's click it. Perfect! So as you can see, Azure ML Studio launches in another tab, and we'll explore this in another demo later in this course. In this demo, we're going to inspect the Azure ML Studio sidebar components so you can understand where to find the various tools and components needed for creating machine learning workflows. And we'll do that by simply clicking through each of the sidebar options in ML Studio. Alright, so first we need to head over to the ML Studio in our browser. Perfect. Now you'll see along the left-hand side that there's a menu of options that are all categorized. At the very top, we have the Home menu option. And this is the default option that's selected when we first navigate to the ML Studio. In the home screen, we have a bunch of quick links to get started on some work. At the top of the screen, you can quickly create various resources by clicking on the big Create New Plus button. Then there's quick access to notebooks, automated ML, and the Designer. And we'll get to those later. Underneath all of that, we have a list of all the most recent runs that we've performed and even the compute that we've created. We can go directly to those screens to inspect those resources from here. Then at the bottom is a quick access to tutorials that can help you get started on specific things that you might want to do. Let's go top to bottom on the sidebar and see what each of these options do. The first section we see after Home is the Author section, and this includes options that can be used for creating actual machine learning models. The first option is Notebooks, so let's click on that. Notebooks are an open source web application that can be used to create and share documents, code, equations, visualizations, narrative text, or a combination of all of those capabilities. Microsoft actually includes a whole host of sample notebooks that you can use as soon as you create your ML workspace. In fact, if you click on the sample notebooks at the top of the screen, you can see a couple of folders, one for how to use Azure ML and one for tutorials. If you expand the tutorials folder, you can see a good set of different tutorials that you can use to get started. You can clone any folder into your own local files, and most of the samples will let you get started with pretty minimal effort. Now the next option is Automated ML, so let's click on that now. Now Automated ML lets you train and find the best possible model for a given dataset based on several different algorithms and methodologies. You can run a regression test, a classification test, or even a forecasting test. And you can do all of that without writing a single line of code. Just give it data, and off it goes. And we'll look at this in a bit more detail in some other demo. The next option is Designer, so let's go ahead and click on that option. The Designer is a way to access and manipulate pipelines. With the Designer, you can drag, drop, and connect modules like datasets, transformers, model trainers, and algorithms, all on an easy-to-use canvas. You can arrange those modules to train models and manipulate datasets however you deem necessary. This is the tool that you'd use if you didn't want to automate machine learning with automated ML. Now, after the author section, we find the assets section. And this is where all of the resources and, well, assets that are used to support the actual machine learning authoring can be found. Unsurprisingly, the first item we see in the list is datasets. So let's go ahead and click on that. The datasets option shows us all of the datasets that we have configured in ML Studio so far. From here, we can access all of our datasets. We can also create new datasets by clicking on the Create Dataset option. In fact, let's click on that button for a second. The Create Dataset button requires that we choose one of 4 options. We can choose to create a dataset based on files that we have locally, meaning I can upload a dataset, or we can choose to associate a dataset to a data store. Or we can choose to create a dataset based on files available online. Or we can even choose to create a dataset based on an open dataset available in the cloud. Now, datasets are the lifeblood of machine learning, so this will be an area that you're going to use a lot. Now, the next option is the experiments option, so let's click on that. The experiments screen lists all of the experiments that we've created so far. Each experiment contains runs. Usually an experiment contains many runs. An experiment is all about trying to find the best fit model for your data. Experiments are a good way to group all of your runs together so you can quickly figure out which one is best. Now, after experiments, the next option is pipelines, so let's click on that. Pipelines is sort of another way to look at information. At the top of the screen, there are 3 tabs: Pipeline Runs, Pipeline Endpoints, and Pipeline Drafts. Each time we run a pipeline, it will be shown in the Pipeline Runs tab. And this gives us a shortcut to the specific run that we might be interested in. There's also a way to go to the experiments that run belongs to. The Pipeline Endpoints tab lists all the pipelines for which an endpoint was created. That means that any pipeline listed in this section is actually available to be run from outside ML Studio. And the last tab is Pipeline Drafts. This tab shows us a list of all the pipelines that we can edit. In fact, clicking this tab is basically no different than clicking on the Designer option under Authoring. Now, the next option in the list is Models, so let's click on that now. The Model screen shows us all the models that we've created so far. Experiments and automated ML runs, which are just shortcuts to experiments, will create models. Each model will have information like which experiment it belongs to, when it was created, and whether there are any associated endpoints. If you have a model you like that you want to deploy, you can access the model and choose to deploy it. And we'll talk about that in another demo. Next up, we have endpoints. So let's go ahead and click on that. Endpoints are effectively deployed models. When an endpoint exists, it means that there is a publicly accessible REST URL that external people can use to access and run a model. Not just anyone can access the endpoint, of course. To access an endpoint, you need not just the URL, but also a key, and you can use this screen to reset those keys as well. Now, after the Assets section, we find the Manage section. This is where we can access and manage some of the services that are built into ML Studio. Now, at the top of the list is the Compute option, so let's go ahead and click on that. The Compute section is where we can manage and configure all of the computing power that we need to perform some of the actions we'll be doing in ML Studio. The first tab is Compute Instances, and this is where you can set up VMs that you can use for any notebooks that you'll create and run in the Notebooks section. The next tab is Compute Clusters. This is where you'll set up your clusters so that you can run things like experiments. And the next tab is Inference Clusters. This is where you can attach external clusters like Azure Kubernetes. And finally, there's the Attached Compute tab. Now, this is where you can attach your own external compute systems like VMs, HD Insights, Azure Databricks, and so on. The next option in the list is Data Stores, so let's go there now. Data Stores is where we can set up secure connections to external data sources like Azure Blob Storage, Azure File Shares, Azure SQL, and so on. Creating a data store means creating a dataset to access it. And finally, let's click on one more option in the list, Data Labeling. This is where you can create labeling projects. Labeling projects are a way for you to be able to give people access to datasets and have them go through each item in the dataset and provide labels. These people are usually referred to as labelers. Labeling projects gives you the ability to send out links to people to perform labeling while you can gauge the progress of that labeling process. This includes knowing how much of the dataset has been labeled and how many people have gone through and labeled that data. And that's Azure ML Studio. In this demo, we're going to create a dataset from blobs stored in an Azure storage account. To do that, we're going to create a storage account, create a blob store, and add some content to that store. And then we're going to use Azure Machine Learning Studio to connect to it. We'll know our dataset has been created when we can explore it in the portal. Now, being able to connect to a storage account like this is great for situations where you want to add more and more files for AI processing later down the road. So the first thing we need to do is head over to the Azure portal. Now we want to create a storage account, so let's click on the Create Resource link. Now let's search for Storage Account. And then we'll choose to create one. Now when we create our storage account, it's important to put it in the right resource group. Now I'm going to put mine in the same SBTest-RG resource group that we've been using so far so that I can easily clean up after myself by just deleting the whole resource group when I'm done. So let's find and select that resource group. Now the storage account name can be just about anything you want, but it will have to be globally unique, no spaces, no special characters, and less than 24 characters. Okay, so I guess it can't be anything you want. Anyway, I'll use my unoriginal SBTest storage with some random numbers at the end. Now all the rest of the settings can be left as their defaults, so we can now click on Review and Create. And then Create. Now it'll take a few moments to create the storage account, so let's wait for it to be completed. Alright, now that our storage account is created, let's click on the handy Go To Resource button so that we can add some data to it. Now on the left-hand side of the resource group, we can see all sorts of options. What we want to do here is add some dataset files. So let's scroll down to the Blob Service section and click on the Containers option. Now all blobs need to be stored in a container. What we're going to do here is we're going to upload a dummy dataset from Microsoft that includes some bike rental data. So let's create a container that represents that data. Let's click on the Add Container button at the top of the page. Now in the panel on the right side of the screen, let's give our container a name that represents the data. So I'm going to call my container Bike-Rentals. Good. Now let's click on the Create at the bottom of the screen. Excellent. So now we have a container. Now let's click on it. Now we can see all of the blobs in this container, and of course it's empty. So let's add some data to it. Let's click on the Upload button at the top of the page. Good. Now I'm going to upload a sample dataset from Microsoft, and I'll include that sample in the doobly-doo so that you can use it too. Anyway, let's browse for the file. Good, and now let's click Upload. Alright, so now we have a file in our blob storage, but before we can use it, we need to have an access key. So let's go back to our storage account view by clicking on its name in the breadcrumb. Now let's click on the Access Keys option in the left-hand menu. Next, let's copy the key 1 value. Now you can copy and paste that into Notepad, or you can just keep it in your clipboard, because we're going to be using it right away. Now we're ready to use our blob, so let's go over to ML Studio. Now I've already got mine open in another tab, so I'm just going to click over to it. Perfect. Now along the left-hand side, we can see a bunch of different options that we can select. Now what we want to do here is create another dataset. So let's click on the Datasets option under Assets. Good. Now let's choose the Create Dataset button right in the middle of the screen. And since we want to create a dataset based on our own blob storage, let's choose the From Data Store option. Perfect. Now we're asked to configure our dataset. First, it wants a name. So let's give our dataset a name that shows it's coming from a blob store. I'm going to go with dset-bike-rentals-blob. Good. Now we can click Next. Next, in the Data Store selection step, let's choose to create a new data store. Now we need to give our data store a name. So I'm going to go with dstore bike rentals blob with no spaces. Next, let's choose the Azure Blob Storage from the data store type selections. And now we can choose our storage account that we created earlier. And now we can select the blob container, which for me was bike-rentals. And now we can paste our access key into the account key field. And finally, we can click the Create Data Store at the bottom of the form. Next, we need to provide information about where in the blob container we can find the files we care about. In our case, we want all the files in the blob container, so we're going to provide a path of /*. And now we can click Next. Excellent! The Settings and Preview step is starting to see our data. Now let's make sure that we can select that there are column headers here so that they're not included in the dataset. Good. And now we can click Next. Now in the Schema step, we're going to make sure that all the columns are turned on except for Path, and then we'll click Next. And finally, we'll click Create. Now, the dataset may take a few moments to create, so let's wait for it. Looks like it's already done. All right, that means we have a dataset. So let's confirm that. Let's click on the Bike Rentals file dataset. And now let's click on the Explore tab. All right, look at that. So much beautiful data. Great job. In this demo, we're going to create and configure a compute instance, as well as a compute cluster in our Azure Machine Learning workspace. To do that, we're going to use the Azure Machine Learning Studio tied to our Machine Learning workspace. We'll know our compute has been created when the Studio shows our instance and our cluster as running in the portal. Now, the first thing we need to do is head over to the Azure ML Studio in our browser. Now, as we've seen so far in this course, Azure ML Studio has all kinds of capabilities along the left-hand blade selection area. In this demo, we're going to focus on creating some compute capability. So let's click on the Compute blade in the Manage area. Now, there are all kinds of different compute that you can use. There are compute instances, which are like VMs, compute clusters, which are clusters of VMs, inference clusters, like Kubernetes, and attached compute, which is a sort of bring your own VM. So let's start with creating a compute instance. Compute instances are required whenever we want to execute some of our own code in the Notebook section. Anyway, first let's make sure that we're in the Compute Instances tab, which we are. And of course we don't have any compute instances created yet, so we're presented with a nice easy button called Create that we can click on. So let's go ahead and do that. Now we're going to keep this nice and simple. We don't need anything huge or fancy here. So for our compute instance, let's select the simplest virtual machine available. In this case, let's select the standard DS2 V2 virtual machine right at the top of the list. Good. Now let's leave the rest as default and click Next at the bottom of the screen. Now Azure will ask us for a name for our compute instance. And again, since I'm not very creative, I'm just going to call it sbtest-compi. Good. Now we can click Create at the bottom of the screen and get the creation process underway. Now, this might take a few moments to work, so let's wait for it. Perfect. Now we can see that our instance has been created, and that's good news. This will mean that if we want to run some custom code in the Notebook section, then we can have a dedicated compute instance that we can use. In fact, let me quickly show you how that would work. Let's click on the Notebooks section. Now we don't have any notebooks in here, so let's create one. Click on the Create button in the middle of the screen, and let's select Create New File. Now we can give our file a name, and this is just a dummy file for now, so let's call it temp. And now we can click on Create. Good. Now notebook files allow us to create and execute code blocks and test certain things. But code can't just run in thin air. It needs to be run on a server, right? Well, that's where the compute instance comes in. Notice in the toolbar that our notebook has our compute instance automatically selected. That means that if we wrote any code in this notebook and then executed it, it would run on our freshly created instance. All right, but that's not all the compute that we would ever normally need. We would also normally need to create a compute cluster. We normally need a cluster because deployed machine learning models run on clusters, not instances. So let's do that. Let's create a cluster. Let's go back to the Compute blade. And now let's click on the Compute Cluster tab. Good. Now let's click Create. Now we're going to keep this pretty easy too. For our compute cluster, let's select the same simple VM that we picked for our instance before. Specifically, let's select the standard DS2 v2 virtual machine right near the top of the list. We'll leave the rest as the defaults, and then we can click Next at the bottom of the screen. Now next, Azure will ask us for a name for our cluster, and again, since I'm not very creative, we'll just call it sbtest-comp-c. Now notice that there are lots more settings here than when we created a compute instance. That's because your cluster can have as many nodes as you want, and can even automatically scale down when things go idle for a bit. In our case, we'll set the minimum nodes to 0 and the maximum nodes to 1. That means that we'll have one VM available in the cluster whenever needed. But when it's idle, it'll shut everything down. And that's good, especially if you're using a free trial. Now we can click Create at the bottom of the screen and get the creation process underway. Now this may take a few moments to create, so once again, we'll wait for it. Perfect! Now we can see that our cluster is running. Excellent! This means that we have a machine learning workspace with a configured compute instance so that we can run code, and a configured compute cluster so that we can deploy models. Great job! So in this course, we've examined the machine learning services provided by Azure. We did this by exploring Azure Machine Learning Services and Azure ML Studio, creating an Azure ML Studio account and accessing the dashboard, Azure ML Studio sidebar components and their use, Azure Blob Storage data ingesting, and creating a compute resource. In our next course, we'll move on to examine available Azure Machine Learning regression models.